Today we are going to discuss the third video, which is based on ideal and non-ideal solutions. What is an ideal solution? The solution which obey Raoult's law over the entire range of concentration are known as ideal solution. What are the conditions for an ideal solution? An ideal solution will satisfy the following condition. Number one, there will be no change in the volume on the mixing of the two components, that is solute and solvent, since both are liquid. So what this is? Ideal solution which obeys the Raoult's law completely. You must be recalling the graph for the Raoult's law of volatile liquid mixture. So it is the P total. This is P naught B is the vapor pressure of pure solute. P naught A is the vapor pressure of solvent. And when the two solutions are mixed, what you find? Vapor pressure of the total vapor pressure of the solution becomes equal to PA plus P. Now, the characteristics are, all the conditions for a solution to be an ideal are: number one, there will be no change in the volume on mixing the two components. Suppose 10 ml or 10 liter of liquid A and 10 liter of liquid B are mixed in a container. So the total volume of the solution on mixing the two liquid in the container should be 20 liter. That means change in volume will be 0, because 10 liter of liquid A and 10 liters of liquid B are taken, and which on mixing do not showing any change in volume, then it is said to be an ideal solution. Condition number 2, there will be no change in enthalpy when the two components are mixed. What happens when the two components are mixed? The interaction between the solute and solute particle undergo dissociation, and it absorbs energy in that case. Similarly, interaction between B and B goes on dissociation, and that also absorbs heat. And when A and B are mixed together and form a bond, that is AB is formed, then heat is released. So heat, if the heat absorbed in breaking the bond between component AA and bond between the component BB are of 10 kilojoule and 10 kilojoule, that means total energy required to dissociate the bond between two A component and two B components are 10 kilojoule respectively, then 10 plus 10, 20 kilojoule. And if the energy released on the formation of two A-B molecule, two molecules of AB, if is 20 kilojoule, then the solution is said to be ideal. That means heat absorbed 10 kilojoule plus 10 kilojoule, and heat released two times the force of interaction between A and B. So it will be 20 kilojoule. If it is 10 kilojoule, and if it is 10 kilojoule, which is the energy required to dissociate the bond between the A and A particle, similarly 10 kilojoule is the energy required to dissociate the bond between B and B particle, then how much energy will be released? AB. If it is an ideal solution, then 2 moles of AB will be formed, and the energy released in that process will be 20 kilojoule. If it satisfies this condition, then the solution is said to be an ideal. Third, for a solution to be ideal, the P observed, that means vapor pressure of the mixture of solution at any given temperature, must be equal to the theoretical vapor pressure. Means theoretical vapor pressure and observed vapor pressure. Theoretical vapor pressure will be P total will be PA plus PB. You know well that PA equals to XA into P naught A. Similarly, PB equals to XB into P naught B. So P total will be P naught A into XA plus P naught B into XB. This is the theoretical vapor pressure. and the vapor pressure, observed vapor pressure, that we will calculate from the apparatus, that is nanometer or barometer. So if the two vapor pressure comes equal, then the solution is said to be an ideal solution. So for a solution to behave and follow the Rawls law completely over the entire range of concentration, these four conditions are to be satisfied. Number one, what are the examples of ideal solution? The examples are, also do know that for solution forming ideal solution means component of an ideal solution are forming a homogeneous mixture. They are perfectly miscible. So the examples are benzene plus toluene. Why they are all ideal? Because this is the formula of benzene, this is the formula of toluene, and they are of the comparable molecular masses. Likewise, normal hexane and normal heptane, mixture of these two are the ideal solution. Chloroethane and bromoethane, mixture of these two are the ideal solution. Chlorobenzene and bromobenzene, these are the components of comparable molecular masses which are forming the ideal solution. So an ideal solution is that which obeys Rawls law over the entire range of concentration, and its graph should be like this. Non-ideal solution. What are non-ideal solution? A non-ideal solution is that which does not follow the Rawls law over the entire range of concentration. That means delta V mixing should not be equals to 0. Delta V mixing should not be equals to delta H mixing should enthalpy change on mixing the two components are to be 0, and volume change also should not be equals to 0. So these are the two conditions that require to be fulfilled. Enthalpy change should not be equals to 0. Either heat will be released or the heat will be absorbed. Similarly, on mixing the two components of a solution, if there is a volume change, either it increases or it decreases, then the sum of the volume of the two components, then it is said to be non-ideal solution. So any solution which does not obey Rawls law over the entire range of concentration are said to be non-ideal solution. What are the types of non-ideal solution? Non-ideal solutions are of two types. For an ideal solution, what we learned previously, that P observed and P theoretical must be. For non-ideal solution, P observed will not be equal to P theoretical. Either it will be less or it will be greater. So based on that, we can divide the non-ideal solution into two parts. Number one, non-ideal solution showing positive deviation. It is obvious from the graph here. It is here the mole fraction of A equals to 0. So there is no vapor of A, only the mole fraction of B equals to 1. So this is the vapor pressure pure component B. Likewise here XA equals to 1, XB equals to 0. That means it is representing the vapor pressure of pure liquid A. On mixing the two, in between these two, there are moles of A and B both. So each component have a fraction of moles. Either, that means it will be less than 1 mole, A will be also less than 1 mole, and sum of the two will be equals to 1. So if on the mixing the two solution, the vapor pressure of P total equals to PA plus PB, if it is above this graph showing positive deviation, then it is said to be. That means P observed pressure, vapor pressure of the observed solution is greater than the P theoretical P ideal. If the P observed is greater than the P in ideal case, then it is said to be non-ideal solution showing positive deviation. Apart from that, there are other conditions are also which require to be fulfilled. What are those? A solution showing positive deviation means the interaction between the two component A and B are very weak. That means FAB is less than FAA and FBB. That means the two solutions hate each other, then they are showing the positive deviation from the ideal behavior. So it is a non-ideal solution with positive deviation. Thirdly, what will be the volume? On mixing the two solutions, as the force of interaction between the component A and B get lower, that means it will occupy more volume. So the change in volume will be greater than 0. So volume of the mixture will be greater than the sum of the volume of AA and volume of BB. Fourth condition, enthalpy change should also be greater than 0. That means energy required to dissociate the bond between the component AA and BB, sum of these two should be greater than energy released on the formation of A and B. That means enthalpy change, heat should be, it is endothermic. Non-ideal solution, delta H is positive, that means it is endothermic. More heat is required to dissociate the old bond and less energy is released on the formation of the solution. What are the example of the non-ideal solution showing positive deviation? Alcohol, methanol plus water, ethanol plus water, carbon tetrachloride plus acetone. They repel. In acetone, we have dipole-dipole interaction. When this molecule comes, that interaction gets lower. Likewise, ethanol has hydrogen bonding. So when acetone molecule comes between the two ethanol molecule, the interactive force gets decreased. CS2 and acetone. CS2 is non-polar and acetone is a polar molecule having dipole-dipole interaction. So when CS2 is mixed into acetone, dipole-dipole interaction will get lower, so they will show the positive deviation. Now, other type of non-ideal solution is non-ideal solution means non-ideal solution showing negative deviation. What does it mean? It means that the P observed of the non-ideal solution is less than the P theoretical, which is clear from the graph. This is the P total for an ideal solution. P total equals to PA plus PB. And what is PA? PA equals to PA naught into XA. PB equals to P naught B into XB. So if what you see here, that is dotted line, it is the non-ideal solution. These dotted lines are the non-ideal solution. Non-ideal solutions are shown by the dotted lines. So what we see that these lines, dotted lines, are below the solid lines. That is, it is the ideal. Solid lines are representing the ideal solution and dotted lines representing the non-ideal solution. What is obvious from this picture, this graph, is that non-ideal solution showing negative deviation has less P total than the ideal solution. So P observed for non-ideal solution must be lower than the P theoretical. Number 2, the intermolecular force of attraction between the component A and B must be greater than the force of interaction between the component AA and force of interaction between the component BB. So what does it mean? On mixing the two solutions, molecules or A and B comes more closer with respect to molecule in liquid A. That means the distance between AA and distance between BB is more as compared to the distance between FAB. Force of interaction is more. So these are the solution. Non-ideal solution showing non-negative deviation must be loving each other. The two components must be attracting each other. that solution is only show the negative deviation. And for that, delta V mixing equals less than 0. Delta H enthalpy change of the solution should be less than 0. It will show negative deviation. That means in this case, energy released is more than the energy required for decomposition of bonds between AA and BB. Then delta H will be negative. That means it is exothermic. Delta V is also negative. That means what? The two components, if 5 ml of A, 5 ml of B are mixed together, total volume should have been 10 ml. But what you will observe, total volume in the container on mixing the two solutions reduces to 8 ml. So delta V mixing is less than 0. What are the examples of non-ideal solution? Acetone and chloroform. It's a very common example given in NCERT book. Phenol plus aniline. This is also in the NCERT book. HNO3 plus water. It is given in the NCERT book. Likewise, HCl and water. Acetone and aniline. So what are the interaction between these two? Acetone and chloroform. In acetone, this is the formula of acetone. And this is the formula of chloroform. So in between here, there is a H bonding. And because of the increased bond strength, it is showing the negative deviation. Am I clear to all of you? So revise this topic. Ideal solution, non-ideal solution. And what is the reason for the non-ideal solution? Either the enthalpy change or the volume change should be greater than 0 or less than 0. What are the examples for solution showing positive and negative deviation? For positive deviation, P observed vapor pressure should be greater than the theoretical vapor pressure. And non-ideal solution showing negative deviation, for that P observed should be less than P theoretical. Now there is a very important topic really based on these two, that is called azeotropes or azeotropic mixture or constant boiling liquid mixture. What are the conditions? What are the characteristics of azeotropes? So first of all, understand what is azeotropes. Azeotropes are the binary solution. That means a solution having two components only, two liquids only, not more than two liquids. Number two, they have fixed composition in the liquid as well as vapor phase. That means on mixing the two solutions, the mole fraction in the liquid phase of each component and mole fraction in the vapor phase of each component must be the same. Third, the solution must boil at a constant temperature, which will be either greater than the boiling point of the either component or can be less than the boiling point of the each component. Although we know that different liquids have different boiling point because of the different intermolecular forces of attraction. But in azeotropic mixture, what we find that they boils at a common temperature, common fixed temperature. They have a fixed constant boiling point. And the fourth and the foremost important factor is that they cannot be, an azeotrope cannot be separated by a fractional distillation method. Fractional distillation is not possible. If these four criteria are fulfilled by a binary solution, then such solution is said to be azeotrope or constant boiling liquid mixture, binary mixture having same composition in liquid and vapor phase and which boils at the constant temperature is called azeotropic mixture. Now, what are the types of azeotropic mixture? There are two types of azeotropic mixture. One is minimum boiling azeotrope and other is maximum boiling azeotrope. We will compare the two azeotropes here only. Minimum boiling point depends on the vapor pressure. When the vapor pressure of any liquid becomes equal to atmospheric pressure, then it is said to be boiling. The temperature at which the vapor pressure of the liquid becomes equal to the atmospheric pressure is called boiling point. So all of us knowing this. So what happened minimum boiling vapor pressure? Minimum boiling azeotrope, that means azeotrope forming more vapor. That means they are more volatile on mixing. That means what? That if the vapor pressure gets increased, that means solution, non-ideal solution showing positive deviation. Vapor pressure get increased means showing positive deviation. So if P observed is greater than P theoretical, that means a non-ideal solution of fixed composition showing positive deviation from Rolle's law are said to be minimum boiling azeotrope. And the very common example is the ethanol plus water. Are all composition of these two liquid is azeotrope? No. 95% of ethanol and 5% of water by volume is said to be minimum boiling azeotropic mixture. Once again, I am repeating, 95% aqueous solution of ethanol by volume is minimum boiling azeotrope, because this solution is showing 95% aqueous solution of ethanol is showing positive deviation from the Rolle's law. This is the positive deviation from the Rolle's law. What is the maximum boiling azeotrope? A non-ideal solution of fixed composition showing negative deviation from Rolle's law is said to be minimum boiling azeotrope. That negative deviation, do remember, this is the solid line representing the vapor pressure of the pure liquids A and B. This is PB, this is PA, and this is P total. And this dotted line, it is the observed on mixing the two solution. Here is the both moles are present, moles of liquid A and B are present in between these two. Here at this origin and at this origin, there are pure components, but between these two, there are mixture of the two components. So what P total, what we observe, is less than the P theoretical, which is represented by the dotted lines. So a non-ideal solution of fixed composition showing negative deviation from the Rolle's law is said to be minimum boiling azeotrope. And very common example is 68% HNO3 solution in water. That means 68% HNO3 and 32% of water by mass is the minimum